In order to determine the permanent shear strain developed in the bolt having a diameter of 1.25 inch that is connected to the lap joint as shown in the figure, whereas the material properties are given to us via a stress strain diagram. In this case, a load of 150 kilopound is applied to the joint, and then this load is removed. Here we are looking for what will be the permanent strain developed in the shear plane of the bolt. So that can be given as gamma P. Now, in order to figure out this strain, first of all, we have to figure out the shear force that is developed in the bolt. So let's go ahead and develop our free body diagram. Here we have a load of 150 kilopound going towards the right, whereas since it's a lap joint, we have the two shear forces going towards the left given by the variable V. Now, if we apply our equilibrium equation, we can simplify and solve for the value of V that is equals to 75 kilopounds. Now, once we have the shear force, let's go ahead and identify the shear stress value. Now, the formula for the shear stress is force over cross-sectional area. In this thing, shear stress is given by the variable tau that is equals to V over A. Now we have already calculated the value of V, that is 75 kilopounds, dividing with the cross-sectional area of the bolt. Here we are given a diameter that is equals to 1.25 inches. So the cross-sectional area will be pi over 4 times 1.25 square. Simplifying, we get our value of shear stress as 61.12 KSI. Now, once we have the value of shear stress, let's go ahead and identify the shear strain from our stress strain diagram. So at the value of 61.12, here we have defined a variable gamma, that is the shear strain due to the application of 150 kilopound load on the lap joint. Now, to calculate this gamma, we can apply the interpolation since we know the value of shear strain at the 75 KSI shear stress, as well as we know the value of shear strain at 50 KSI of the stress. So we can apply the interpolation function, that is gamma minus 0.005 divided by 0.05 minus 0.005, that is equals to 61.12 minus 50 divided by 75 minus 50. Now simplifying, we are getting the value of our shear strain as 0.02501 radians. Now this value is the total shear strain that will be developed in the bolt once we apply the force of 150 kilopound. However, in the question, they are asking us to figure out what is the permanent strain when this load is being removed. So in this case, once the load is removed, some of the material is going to recover, and it will follow the same slope as the slope of linear elastic region. Now let's first identify that slope value, that is our shear modulus G. And once we have that, we can go ahead and figure out the recover strain and the permanent strain value. So to solve for the value of G, we can apply our Hooke's law, that shear stress is equals to shear modulus times shear strain. And since we are looking for the linear elastic zone, the value of tau is 50 KSI and the strain value is 0.005. Simplifying, we get our value of shear modulus equals to 10 times 10 raised to power 3 KSI. Now, since this slope is the same as the recovery part, so we can again apply the same formula, that tau is equals to G times gamma, but at this times the gamma is the recovered gamma. So at the shear stress value of 61.12 KSI and our shear modulus value of 10 times 10 raised to power 3 KSI, we can simplify and solve for the recovered shear strain, that is coming as 6.112 10 raised to power negative 3 radian. Now, once we have the value of recovered strain, in order to calculate the permanent strain that will be developed in the bolt, we just need to subtract the recovered part from the total strain value. So, simplifying, our value of total strain was 0.02501, whereas the recovered strain is 6.112 10 raised to power negative 3. Subtracting the two terms, we get our permanent strain value equals to 0.0189 radians.